In this example, we're given this diagram with three lines, three intersecting lines, and a bunch of angles labeled. We are given that angle 4 is not congruent to angle 8. Okay, so angle 4 is not congruent to angle 8. I'm just going to shade these in. Angle 4 and angle 8 are the ones in question. And we're asked to prove that the line L is not parallel, to the line M. So these two lines L and M are supposed to not be parallel. So this statement, so remember that our statements have, our theorems have hypotheses and conclusions, right? And so this is our hypothesis, H, and this is our conclusion, C. And what we were trying to prove is if H, then C, or in just symbolic notation, the logic notation for this is H implies C. Hypothesis implies conclusion, right? So H implies C. Now remember, there is a note. I'm thinking here because I see all these slashes, the not congruent to, not parallel. I'm thinking about negations, right? And so remember that there is a property called of these logical conditionals called the contrapositive. So the contrapositive of this statement states, remember how it works. It negates both of them and changes the order. So this is going to be not C implies not H. So if you negate the conclusion, then it implies that the hypothesis was not true. And this one is equivalent to the original statement, okay? So as far as logical statements go, H implies C is equivalent. This is very important, all right? These are equivalent statements. It's equivalent to not C implies not H. All right, so this is going to be, I'm going to do it by an indirect proof, because when you negate a negation, you end up with, the two negations cancel out. You end up with just a statement altogether. So if I want to change this around, now my given is going to be not C, right? And so not C says what? The opposite of this. So it's going to say, all right, the given is going to be that L is parallel to M, all right? And the prove, this is the new conclusion, is going to be the negation of the old hypothesis, right? So not H. Well, that again, if you're not equivalent, then you are congruent, right? If you're not congruent, you become congruent. So angle 4 should be congruent to angle 8. All right. So what we can do is we can prove this statement, and then we can deduce our original statement by invoking this law of contraposition, or the contrapositive rule. All right, and it turns out that this proof is pretty straightforward, so let's do it. We don't even need a very wide table for this one. So I'm going to make my table, my formal proof table, and then we can write down our statements and our reasons. So there's our statements column, our reasons column. So number 1, this time what we're given is that L is parallel to M. All right. So L is going to be parallel to M, and the reason for that is it's given, right? So that was given to us. Now we can immediately say that if we assume that L is parallel to M, then angle 4 is congruent to angle 8, and that is because those are corresponding angles, right? Corresponding angles of parallel lines cut by a transversal. So we can immediately state our conclusion. So angle 4 has to be congruent to angle 8, and this is by congruent angles. Right? Congruent angles. But then what we actually get from all this is that we can now deduce, right? We can deduce that actually this statement is true, right? The original statement. All right, so here's how I'll write it. It doesn't have to be part of the table. So now we can just say, by contraposition, we may deduce, or we do. Let's not even say may. We're going to do it. We're not just allowed to do it. We're going to do it, right? So we deduce that if angle 4 is indeed not congruent to angle 8, then these lines cannot be parallel, right? All right, and this is an indirect proof by contraposition. It's nice because the direct portion was literally just one line, right? Given, and then we have a rule for why those two angles have to be congruent to one another. I even wrote congruent angles. Of course they're congruent. I meant corresponding angles, right? Those are corresponding angles. So I'm not sure if I said corresponding or not, but I'm sure you guys, if I said it wrong, I'm sure you were yelling at me. Those are corresponding angles. 4 and 8 are corresponding angles of these parallel lines cut by a transversal. Clearly not parallel lines though, right? And so that's where contraposition tells us that the contrapositive statement, right, is true. So this is an example of a very simple proof as far as the table goes, but drawing a conclusion using the law of contraposition, a conclusion that is not a direct result of this table.